Imagine you're in a metal capsule, plunging into the dark depths of the ocean. You're on a mission to explore the most famous shipwreck in history, the Titanic. You're excited, curious, and maybe a little nervous. But you trust your submersible, the Titan, to keep you safe and sound. After all, it's designed to withstand the enormous pressure of the water, up to 4,000 meters below the surface. What could possibly go wrong? Well, a lot. In fact, everything. Because in a matter of seconds, your submersible is going to implode. Yes, implode. Not explode, but implode. That means it's going to collapse violently inwards, crushing you and your crew like a soda can. But how is this possible? Why does implosion happen? And what can we do to prevent it? When a submersible implodes, a rapid change in pressure crushes anything inside, with thousands of pounds of pressure per square inch. The difference between an explosion and an implosion is following. We think of explosions as massive balls of fire and shrapnel, and they certainly are that. But at its core, an explosion is simply a rapid release of energy. What every explosive is trying to achieve is an abrupt change in pressure at the blast site, and they do that pretty well. When an explosive detonates, the fuel inside of it rapidly heats and expands, causing a pressure differential between it and the surrounding environment. The difference in pressure is so severe that the contents of the explosive rapidly expand into the environment. Sure, there is fire and shrapnel, but those are secondary symptoms. Pressure is the real killer. If an explosion is powerful enough, it can create a shock wave of pressure which travels a significant distance from the blast site. The power of a shock wave is defined by its overpressure, the amount of additional pressure added to the environment above the typical atmospheric pressure. Basically, it's a measure of how much force you're actually feeling, since atmospheric pressure more or less balances out. And it takes a surprisingly small pressure difference to do damage. A shock wave carrying 1 pound of additional pressure per square inch is enough to damage houses. 2 pounds of added pressure will cause the partial collapse of walls and roofs. A little more than that and a person's eardrums will rupture. At 3 pounds of added pressure, steel frame buildings are pulled from their foundations. 10 pounds of added pressure will cause the complete destruction of buildings and snap wooden utility poles out of the ground. At or above 20 pounds of added pressure per square inch, and you approach 100% fatalities for anyone in the area. On the other hand, implosions are like explosions running in reverse. There's still an intense pressure differential, but it's crushing in on you instead of trying to burst out.
Container with steam pushes out the air. But if the vessel is sealed while it's still hot, and then allowed to cool, the steam condenses, and the internal pressure drops, meaning the now much greater external pressure pushes in on the surface. And that's bad news for the can.
Oh, there we go. There we go. Oh, it's actively moving. Look at that.
Inside of a submarine or a submersible, the pressure is a comfortable 14.7 psi, just like on the surface. But the pressure pushing in on you is staggering. Even at the Titanic wreck site, considerably higher than Challenger Deep, the pressure is an overwhelming 6,000 pounds per square inch, roughly 400 times that at sea level. While the tragic destruction of the Titan is still being investigated, it's been suggested that minute defects in the submersible's hull caused an almost instantaneous failure of the vessel. If defects were present, they would have been disproportionately vulnerable to the intense pressure at those depths. Once the hull began to buckle, it likely caused an unstoppable collapse. Any vessel with a catastrophic hull breach would experience a rapid change in pressure from 1 atmosphere to hundreds in an instant. It would be like having 2,500 elephants stand on you all at the same time. Implosions aren't as flashy as their more extroverted siblings, but they are just as destructive. During an implosion, the pressure differential between the inside and outside of the submarine can be enormous. The water pressure can be several times greater than the atmospheric pressure inside the vessel. This pressure differential can cause the hull to collapse inwards, crushing the crew and equipment inside. To withstand the external water pressure, submarines are designed with thick, strong hulls that can resist deformation and collapse. However, even the strongest submarines have limits to how deep they can dive and how much pressure they can withstand. Submarine implosions are catastrophic events that can occur due to various reasons such as structural failure, explosion, or pressure changes. Implosion reduces the volume occupied and concentrates matter and energy. The event can happen in different situations, such as in nuclear weapons, fluid dynamics, and astrophysics. Thank you very much for watching and welcome back to our channel.
In and out. Covered.